Good morning and welcome to the world of trigonometry. Let us have a look at what is trigonometry today. So, trigonometry, as you see, this is a website. Now, this mode of teaching that I will do today will be slightly different. It is all screen sharing and interpreting whatever I see on the screen to you. Right now, it's just a website which says what is introduction to trigonometry, but basically, what I want to tell you is trigonometry എന്താണ്. So, whatever they say about the languages, let us split it up into what we know. Trigonometry, trigonometry. Trigonum is നമ്മൾ മലയാളത്തിൽ ത്രികോണം എന്നാണ് ട്രയാങ്കിൾ എന്ന് പറയുന്നത്. Triangle, yes, trigonometry. The word that comes closest to the word metry is meter. Meter is a measure of length. So it's a measure. Okay. So basically, trigonum, 3 is 3, conum is corner. Okay. Metry is meter or measure. Basically, so we have three words here. One is 3, the other is corner, other is measure. So 3 corners and a measure. So basically measurement using 3 corners or triangles. So this is what trigonometry is all about. It is measurement using triangles. This we have to understand. Okay, so before we look at trigonometry, we will look at something called perspective. Very important to understand what is perspective before we venture into trigonometry. We will go not into detail. If you really need a detailed view of what is perspective with the same kind of explanation, I have another video which I have sent to you that will have a detailed one. Whenever you feel you want to look at it, because it is at least a 11-12 minutes video that you can look at it different times, maybe not for your exam preparation, but other times you can look at it. But I will be precise and to the point in this particular thing regarding what is perspective. Look at what is in front of you. It is a color, okay, something like a background color. This is what you feel right now, okay. If you ask me, what I feel is this a slightly kind of it has a yellowish tint to it and a brownish tint to it, a color, that's it. And I am seeing something else also because I can see the outside of it also, because it is my screen that is being shared. My view, my vision of this particular thing is like that, whereas your vision is just a color, okay. So that itself says what is perspective. It is what I see is my perspective and what you see is your perspective. Perspective is what you see, what you see. The emphasis is on you, okay, or I. What you see. Okay, this is perspective. If you change your angle of looking, your perspective changes, okay. To understand what I do is, I'll try to zoom out of what is actually here. This is a part of my animation software and it is an object actually which I'm zooming out. Zooming out. What is this? It's a cube. That's what you understand, okay. Think about it, how you understood it is a cube. Okay, that is because of your old experiences and memories, which makes you understand this is a cube. Actually, it is not a cube. If you just look at it, it's not a cube. It's a two-dimensional shape with a different size, a particular pattern. It's a shape. Okay, you can look at it that way also. But since you have an experience with cube and you assume that it is a cube, you cannot say it is a cube as such. It can be a 1, 2, 3, 4, 5, 6 hexagon and with a shaded portion, a rhombus portion being shaded. You can look at it in different ways. Anyway, so now you look at it, you find it is a cube. In fact, it is a cube. If you look at it, if you look at it like this, you see this cube. I'm not going away or near to the object. I'm just looking around it. Okay. Now what I do is I just move away from it. Okay. I move away from it. What do you see? When you move away from the object size reduces. Is the object size reducing? No, 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 it is not. What is reducing is what you see in your frame of your eyes, in your vision. So when you move away from your object, this object size reduces relative to the frame of your vision. Okay, in the frame of your vision, the object has become smaller and smaller, and it will further become smaller since it becomes till it becomes minute and minute yet, and it becomes negligible enough for you to disregard it or call it vanished. Okay, this is what happens. So what we understand is the further you go away from an object, the smaller it looks like. Okay, this is very important. Looks like, it doesn't become smaller, it looks like. And the closer you go towards an object, it looks like bigger. This is the very important thing which you need to understand regarding your perspective. Your perspective, another person's perspective is different for the same thing. Please understand that. Okay, now let us move forward to the next module. Okay, now take a look at the screen. I'm really sorry for this funny kind of a figure. This is what I could make so fast. So look at this particular picture, a person. Okay, this is a person, and I just cloned this person. Okay, he's standing in front of his own mirror image. Okay, now what you understand from this is this person is the same, and they are standing on the same level plane. Okay, now if you see this, since the height of this person is the same as the other person. Why it is so? Because both of them are the clones of each other, right? One is the clone of the other. So what happens is, if two people stand like this, can I make a rectangle out of it? Don't you think this is a rectangle which I formed? Okay, so why it is a rectangle? Because the height of this is and this is the same. Understand? So very important. The shape that is formed by two people of the same height standing at different distances from each other, x distance from each other. If you see this as x, and if the height of the person is y, you can make a rough rectangle with x and y. Now if you make a rectangle at this level, it will be a rectangle with length x and height y. Length x and height y. Let us clear all this now. Okay, we have cleared everything, and let us look at this picture once again and do a slight modification. Now we have assumed that the height of this person and this person is the same because it has been cloned. Now what we'll do is I will increase the height of this person, make him taller. Okay, let us see what happens when we make this person as slightly taller. Okay, we select this person and we'll try to increase his on the upside. Okay, I think that is tall enough. Now what we do is this person. Okay, let's mark the heights of each of these persons. Now what we look at this person. Okay, and this will be the height of this person. Okay, thickness is less. Okay, this will be the height of this person, and with arrows here, and this is the height of, oops, but it's not really straight enough. Let's make it slightly different. Straight line. No, I need a pen tool. Okay, I have my pen here. It's still not very clear, but still I hope you will understand it. So this is what is the height difference of both the people. Now, similar to what we did before, if we make a shape out of them, okay, of course they are standing on the same horizontal plane. Now if you make a shape out of them, what you get is, and now let's wait, I'll have a 2D shape here, I'll have a straight line. Make a shape like this, and it looks, what does it look like? Let's have a look at it. Now this, if you join here, okay, and then if you join here, and then of course the bottom is already joined in a line. So now if you look at the shape, what kind of a shape is this? This is something called like a trapezium, right? It's not a rectangle, but it's a quadrilateral with the angle has been changed here because of the height difference of the people. The same way, you can look at if the height of this person is lesser, then you can what you can do is you can understand that what happens is this will form a shape something like this, right? So this will go off. So what happens is you will find a shape like this, a trapezium of a different shape, right? So this is what happens, okay? This just for your information, okay? This you will come to understand when we look at the perspective of each person, okay? Now we'll look at the head angle of each person. Let's reset this and have a look at head angles. ഈ പിക്ചർ കാണുമ്പോൾ എനിക്ക് നമ്മുടെ വാമനൻ്റെയും മഹാബലിയുടെയും കഥയാണ് ഓർമ്മ വരുന്നത്. ആ കഥ അറിയാമല്ലോ അല്ലേ? അതിനകത്ത് ഇപ്പോൾ ഇത് നമ്മുടെ മഹാബലിയും ഇത് വാമനനും ആണെങ്കിൽ എന്താ സംഭവിക്കുന്നത്? പെട്ടെന്ന് ഈ നമ്മുടെ വാമനൻ മഹാബലിയോട് ലാൻഡ് വേണമെന്നൊക്കെ ചോദിച്ചതിന് ശേഷം പെട്ടെന്ന് അങ്ങ് വലുതാവുകയാണ്. ഇങ്ങനെ അങ്ങ് വലുതാവും, സൈസിലും ഷേപ്പിലും ഒക്കെ അങ്ങ് വലുതാവും, ഭീമാകാരനാവും അല്ലേ? അപ്പം ഈ ലെങ്ത്ത് കൂട്ടിയപ്പോഴത്തേക്കും ഹൈറ്റ് കൂട്ടിയപ്പോൾ അതാണ് ഓർമ്മ വന്നത്. അപ്പോൾ ഈ പിക്ചറിൽ ഇത് മിസ്റ്റർ മഹാബലിയും ഇത് മിസ്റ്റർ വാമനനും ആണെന്നിരിക്കട്ടെ. അപ്പം നമ്മുടെ മിസ്റ്റർ വാമനൻ പെട്ടെന്ന് മഹാബലിയോട് കഥകളൊക്കെ പറഞ്ഞതിന് ശേഷം ഒറ്റയടിക്ക് അങ്ങ് വളരാൻ തുടങ്ങും അല്ലേ? അപ്പോൾ എന്ത് പറ്റും? ഈ വാമനൻ്റെ സൈസ് അങ്ങ് വലുതാവും ഭയങ്കരമായിട്ട്, ഓക്കെ? അപ്പം നീളമൊക്കെ അങ്ങ് കൂടി തുടങ്ങും. അപ്പോൾ ഇങ്ങനെ നമ്മൾ പുള്ളിയുടെ ഹൈറ്റും വെയ്റ്റും ലെങ്ത്തും ബ്രെഡ്ത്തും ഒക്കെ കൂടി തുടങ്ങുമ്പോഴത്തേക്കും ഇപ്പോൾ മിസ്റ്റർ മഹാബലി എന്താ ചെയ്യണം നോക്കാം. അപ്പോൾ പുള്ളി ഇവിടെ നിൽക്കുകയാണ്. അപ്പം ഇതുവരെ വാമനനെ സെയിം ലെവലിലാണ് കണ്ടുകൊണ്ടിരുന്നത് അല്ലേ? ഐ ലെവൽ. അപ്പം നമ്മുടെ ഐ ലെവൽ വരയ്ക്കുകയാണെങ്കിൽ, ഇപ്പോൾ ഒരു ലൈൻ വരയ്ക്കുകയാണെങ്കിൽ നമ്മുടെ നേരത്തെ ഈ പുള്ളി നോക്കിക്കൊണ്ടിരുന്നത് ഇങ്ങനെയാണ്, ഇങ്ങനെ ഈ ലെവലിൽ, ഇങ്ങനെ ഐ ലെവൽ, ഓക്കെ? അപ്പോൾ ഈ വാമനന് ഒരു പ്രശ്നമുണ്ടെന്ന്, മഹാബലിക്ക് ഒരു പ്രശ്നമുണ്ടെന്ന് വയ്ക്കുക. ഇയാൾ എപ്പോഴും നോക്കുമ്പോഴത്തേക്കും കണ്ണ് ഒരിടത്ത് മാത്രമേ, കണ്ണിൻ്റെ കൃഷ്ണമണിയെ അങ്ങോട്ടും ഇങ്ങോട്ടും അനക്കാൻ പറ്റില്ല എന്ന് വിചാരിക്കുക. ജസ്റ്റ് ഫോർ ഫൺ സേക്ക്, ഓക്കെ? കണ്ണിൻ്റെ കൃഷ്ണമണി അനക്കാൻ പറ്റില്ല, തല മാത്രമേ മൂവ് ചെയ്യാൻ പറ്റുള്ളൂ എന്ന് വിചാരിക്കുക. സിമ്പിൾ തല അങ്ങനെയാണെന്ന് വിചാരിക്കുക, ഓക്കെ? അപ്പം ഈ മഹാബലി വലുതാവുന്നതനുസരിച്ച്, വാമനൻ വലുതാവുന്നതനുസരിച്ച് മഹാബലിക്ക് ഈ വാമനൻ്റെ തല അല്ലെങ്കിൽ കണ്ണുകളിലേക്ക് നോക്കണം. ഇപ്പോൾ ഇങ്ങനെ നോക്കിക്കൊണ്ടിരുന്നത് കാരണം സെയിം ഹൈറ്റ് ആയിരുന്നു നേരത്തെയെങ്കിൽ, ഇനി ഈ വലുതാവുന്നതനുസരിച്ച് മഹാബലിക്ക് എന്ത് ചെയ്യേണ്ടി വരും? ഈ മഹാബലിയുടെ മുഖം കാണണമെങ്കിൽ, അപ്പോൾ വാമനൻ്റെ മുഖം കാണണമെങ്കിൽ, രണ്ടും അങ്ങോട്ടും ഇങ്ങോട്ടും തെറ്റിപ്പോവും. അപ്പോൾ മഹാബലിക്ക് വാമനൻ്റെ മുഖം കാണണമെങ്കിൽ വലുതായിക്കൊണ്ടിരിക്കുമ്പോൾ എന്ത് ചെയ്യണം? അപ്പോൾ വാമനൻ വലുതാവുന്നതനുസരിച്ച് മഹാബലിക്ക് തല ഇങ്ങനെ മുകളിലേക്ക് ടിൽറ്റ് ചെയ്യേണ്ടി വരും അല്ലേ? ഉണ്ടോ? ഇങ്ങനെ ടിൽറ്റ് ചെയ്യണം. അപ്പോൾ വലുതാവുന്നതനുസരിച്ച് ഇത്രയും ടിൽറ്റ് ചെയ്തു. അപ്പോൾ നോക്കിയേ, നേരത്തെ സ്ട്രെയിറ്റ് നോക്കിക്കൊണ്ടിരുന്ന ആൾ ഇപ്പം തല ടിൽറ്റ് ചെയ്യേണ്ടി വന്നു. തല ഇങ്ങനെ ടിൽറ്റ് ചെയ്ത് മുകളിലേക്ക് നോക്കുന്നു. കാരണം ആ ആൾ അവിടെ നിൽക്കുന്ന ആൾ അതേ പൊസിഷനിലാണ് നിൽക്കുന്നതെങ്കിലും ഹൈറ്റ് അങ്ങ് കൂടി. അപ്പോൾ അതേ ആളുടെ കണ്ണ് നോക്കണമെങ്കിൽ ഇയാളുടെ തല ഇങ്ങനെ ടിൽറ്റ് ചെയ്യേണ്ടി വരും. അപ്പോൾ നേരത്തെ ഹൊറിസോണ്ടൽ ആയിരുന്ന ഐ ലൈൻ ഇപ്പം ഓൾമോസ്റ്റ് ഒരു ആംഗിളിലായി ടുവേർഡ്സ് വെർട്ടിക്കൽ മൂവ് ചെയ്തു അല്ലേ. വെർട്ടിക്കൽ ഇതാണല്ലോ, ഇത് ഹൊറിസോണ്ടലുമാണ് അല്ലേ. അപ്പോൾ ഇറ്റ് ഈസ് എൻ ആംഗിൾ ഫ്രം ദി ഹൊറിസോണ്ടൽ ഓർ വെർട്ടിക്കൽ. നേരത്തെ 90 ഡിഗ്രി ആയിരുന്നു ഫ്രം ദ വെർട്ടിക്കൽ, ഇപ്പം അത് കുറഞ്ഞു. ഓർ ഹൊറിസോണ്ടലിൽ നേരത്തെ 0 ഡിഗ്രി ആയിരുന്നു ഐ ലൈൻ എങ്കിൽ ഇപ്പം ഇറ്റ് ഹസ് ഗോൺ എബവ് ദ ഹൊറിസോണ്ടൽ അറ്റ് എ പർട്ടിക്കുലർ ആംഗിൾ. എന്ന് കഴിഞ്ഞാൽ മാത്രമേ ഈ മഹാബലിക്ക് മിസ്റ്റർ വാമനനെ ഈ സമയത്ത് കാണാൻ പറ്റുള്ളൂ അല്ലേ. അപ്പം തല ടിൽറ്റ് ചെയ്യേണ്ടി വന്നു. അപ്പോൾ ഇനി നമുക്ക് വേറൊരു മോഡൽ നോക്കാം. അതായത് ഇവിടെ ഒരു കുട്ടിയുടെ മോഡലുണ്ട്. ഈ കുട്ടിയുടെ തല ഇപ്പോൾ സ്ട്രെയിറ്റ് ആണ്. ഈ കുട്ടി ഇങ്ങനെ മുന്നിലോട്ട് നോക്കിക്കൊണ്ടിരിക്കുന്നു. ഇവിടെ ഒരു കോണ്, പുള്ളിയുടെ ഫ്രണ്ടിൽ ഒരു കോണുണ്ട്. ദർ ഇസ് എ കോൺ ഇൻ ഫ്രണ്ട് ഓഫ് ഹിം അറ്റ് ദ സെയിം ഐ ലെവൽ ആസ് ദിസ് പേഴ്സൺ, ആ കുട്ടി. അപ്പോൾ ഹി ഹാസ് ടു ലുക്ക് സ്ട്രെയിറ്റ് അല്ലേ. ഓക്കെ, സ്ട്രെയിറ്റ് എന്ന് പറഞ്ഞാൽ ദിസ് ഇസ് ദ ഹൊറിസോണ്ടൽ ആൻഡ് ഹിസ് ഐ സൈറ്റ് വിൽ ഓൾസോ, ഐ ലൈൻ വിൽ ഓൾസോ ബി സ്ട്രെയിറ്റ്, അതായത് ഇങ്ങനെ ഇരിക്കും. ഓക്കെ, so this red line or this eye line will be parallel to the ground or the horizontal. Okay, so what is the angle between this line and the horizontal? Since they are parallel, the angle between this and this is 0 degrees. Why it is 0 degrees? Parallel lines never meet. Okay, അപ്പോൾ അതിൻ്റെ angle between them is 0 degrees. Any other angle, those lines will always meet at some point or the other. So നമുക്കിനി എന്താ ചെയ്യേണ്ടതെന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, let us try to increase this. Let us assume that ഇയാൾ എപ്പോഴും ഈ കോണിൻ്റെ ടിപ്പിൽ മാത്രമേ നോക്കുകയുള്ളൂ. he is focused on the tip. So what happens if I increase the size of the cone like this? No, he has to look at the tip. Again, what he does is കണ്ണിൻ്റെ കൃഷ്ണമണി നീക്കാം, പക്ഷേ നിൽക്കുന്നില്ല. നമ്മൾ അയാളുടെ ഹെഡ് ടിൽറ്റിങ് ചെയ്യേണ്ടി വരും. കാരണം ഭയങ്കര സൈസ് കൂടുമ്പോൾ എന്തായാലും ഹെഡ് ടിൽറ്റ് ചെയ്യണം. ലെറ്റ് അസ്യൂം ഹി ഹാസ് ടിൽറ്റഡ് ഹിസ് ഹെഡ് ഓർ ഹിസ് ഐ സൈറ്റ്, ഹിസ് ഐ ലൈൻ ഹാസ് ടു ചേഞ്ച്. ഹെഡ് ടിൽറ്റ് ചെയ്യോ ഐ ടിൽറ്റ് ചെയ്യോ എന്ത് വേണമെങ്കിലും ചെയ്തോളൂ. വാട്ട് ഹാസ് ടു റിയലി ചേഞ്ച് ഇൻ ഓർഡർ ടു സീ ദിസ് പർട്ടിക്കുലർ പോയിന്റ് ഇസ് ഹി ഹാസ് ടു ചേഞ്ച് ദിസ് ഐ ലൈൻ അല്ലേ. അപ്പോൾ അത് മാറ്റേണ്ടി വരും. അപ്പോൾ അതിനെന്താ സംഭവിക്കുക എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, ലെറ്റ്സ് ട്രൈ ടു tilt this, let's try to tilt this person like this so that the eye line matches here. Almost I think this increase the size of this one, then we will come to this. Okay, so now when the head is tilted like this, ഇപ്പം ഇവിടെ ഇങ്ങനെ കാണാൻ പറ്റും അല്ലേ. അപ്പോൾ ഇപ്പോഴും ടിപ്പ് കാണാം. അപ്പോൾ ഇപ്പം നമ്മൾ നോക്കുകയാണെങ്കിൽ എന്താ സംഭവിച്ചിരിക്കുന്നു, ഇവിടെ ഇയാളുടെ തല ടിൽറ്റ് ചെയ്തേക്കുന്നത് ഇത്ര ആംഗിളിലാണ്. അതായത് ഐ ലൈൻ ഇത്രയും ടിൽറ്റ് ചെയ്തു. അപ്പോൾ ബേസിക്കലി തല അത്രയും ബാക്കിലോട്ട് ടിൽറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ ഐ ലൈൻ ഇത്രയും മുകളിലേക്ക് ടിൽറ്റ് ആവും. അപ്പോൾ ഹൊറിസോണ്ടലുമായിട്ട് വാട്ട് ഹാപ്പൻഡ് ഈസ്, എന്ത് സംഭവിച്ചു ഇവിടെ കാണാമോ, ഈ സ്ഥലത്ത് you see there has been formed a angle. Let us call this angle as theta. Okay, this angle, ഈ ആംഗിൾ മുകളിലേക്ക് നോക്കിയപ്പോഴാണ് ഈ പുള്ളിക്ക് ഇപ്പോഴും ഇത് കാണാൻ പറ്റണത്. അപ്പം ഐ ലൈൻ ടിൽറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ ഇത് ഇപ്പോഴും കാണാൻ പറ്റും. ഹൗ മച്ച് ആംഗിൾ ഹി ഹാസ് ചേഞ്ച്, തീറ്റ, വിച്ച് ഇസ് കോൾഡ് ദി ആംഗിൾ ഓഫ് എലിവേഷൻ. elevation. Okay, so this is very, very important. ഇനി ഇതേ ആള് താഴോട്ടാണ് നോക്കുന്നതെങ്കിലോ, താഴോട്ട് ലുക്കിംഗ് ഡൗൺവേർഡ്സ്, then what happens? There is this horizontal, okay, which is parallel to the ground, Avidanna, he is looking down because the cat is actually down. So he has to tilt his head downwards by an angle theta from the horizontal. Okay. Then what happens is his eye line is now in line with the cat. Then only he can see the cat. So that much he has to tilt his head, that much angle. So this angle where he has to tilt his head downwards is called the angle of depression. So this is angle of depression, and the other one where you had to tilt the head upwards was the angle of elevation. So this is very simple concepts where you have the angle of elevation and the angle of depression. ഇനി നമുക്ക് മറ്റൊരു കുറച്ചുകൂടി ഹയർ ലെവലിൽ നോക്കാം. ഇത് ഒരു മരവും ഒരു കാർട്ടൂൺ ക്യാരക്ടറിനെയൊക്കെ നമുക്ക് ഇതിനകത്ത് കൊണ്ടുവന്നിട്ട് ഇവിടെ നമ്മുടെ ഒരാൾ ഇവിടെ ഉണ്ട്. ഇവിടെ ഒരു ട്രീ. ദർ ഇസ് എ ട്രീ ആൻഡ് എ ക്യാരക്ടർ. ഓക്കെ. നൗ ഇനി നമ്മൾ ചെയ്യാൻ പോകുന്നത്, ലെറ്റ് us have a look at this character. Okay, this is this nice character, and this character can turn. Okay, right. ഈ ക്യാരക്ടർ ആ മരത്തിനെ നോക്കുകയാണ്. ഓക്കെ. ഇപ്പോൾ കുറച്ച് ദൂരെയല്ലേ മരം, അപ്പോൾ മരം ദൂരെയാണ്. അപ്പോൾ നമുക്ക് ഈ ക്യാരക്ടറിന് നമുക്കൊരു ഒരു ഒരു ചെറിയ ബൈനോക്കുലർ പോലെയുള്ള ഒരു ഇൻസ്ട്രുമെൻറ്റ് കൊടുക്കാം. ഈ ബൈനോക്കുലർ വെച്ചിട്ട് ഈ ക്യാരക്ടർ ഈ ഒരു മരത്തിനെ നോക്കുകയാണ്. എന്തിനാണ് ഈ ഇങ്ങനത്തെ ഒരു ബൈനോക്കുലർ അല്ല, ചെറിയൊരു ഒരു ഒരു കുഴൽ പോലെയുള്ള ഒരു ഇൻസ്ട്രുമെൻറ്റ്. ഇതുകൊണ്ടുള്ള ഉപയോഗം എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ, ഇത് നമുക്ക് ഇതുവഴി നോക്കുമ്പോഴത്തേക്കും ഈ ആൾക്ക് ഒരു കണ്ണടച്ച് ഒറ്റ കണ്ണ് വഴി നോക്കുമ്പോൾ ഒറ്റ പോയിന്റ് മാത്രമേ കാണാൻ പറ്റുള്ളൂ. അതുകൊണ്ട് തന്നെ ഇപ്പം ഫോർ എക്സാമ്പിൾ ദിസ് പേഴ്സൺ വെൻ ഷീ ലുക്സ് അറ്റ് ദിസ് പർട്ടിക്കുലർ ട്രീ, സോറി, ലെറ്റ്സ് ഡ്രോ എ ലൈൻ ഹിയർ. ഇപ്പോൾ ദി ഐസൈറ്റ്, ലൈൻ ഓഫ് സൈറ്റ് എന്ന് പറയുന്നത്, ദിസ് ഇസ് ദ ലൈൻ ഓഫ് സൈറ്റ്. ഓക്കെ, ദിസ് ഇസ് ദി ഹൊറിസോണ്ടൽ ലൈൻ, ദിസ് വിൽ ബി parallel to the horizontal. Okay, so it exactly cuts at this point, so this person will be able to see this particular point only. Okay, so e height ana e height for if you compare, if you just draw a curve, if you draw a curve here, okay, this curve, sorry, if you draw a curve here, I'll take a pen, brush, and if you draw a pencil, okay, if you draw a curve here, this curve, okay, pencil vanda, I'll try a pen. I'll draw a curve here, sorry, not matching. Okay, this is not coming because there's a character here. Okay, wait. So a 2D shapes is a rectangle. Okay, what will happen is, if you draw a curve with this respect, what you will see is you get a kind of a rectangle. Okay, it's a rectangle. When you draw a curve, the person standing here and his or her line of sight. Okay, this depicts a rectangle. This is just for your information. So the basic idea is, ഈ പർട്ടിക്കുലർ ഒരു സ്മോൾ സിലിണ്ട്രിക്കൽ ടൈപ്പ് ഓഫ് ഒരു ഇൻസ്ട്രുമെൻറ്റിൽ കൂടി നോക്കുമ്പോൾ ദിസ് പോയിന്റ് പേഴ്സൺ ഈസ് ഓൺലി ഏബിൾ ടു സീ വൺ പോയിന്റ് ഓൺ ദ ട്രീ. ഓക്കെ, സോ അസ്യൂം ദാറ്റ് നൗ ഇറ്റ് ഈസ് ഹെൽഡ് ഹൊറിസോണ്ടൽ. ദാറ്റ് മീൻസ് ദി ആംഗിൾ ബിറ്റ്വീൻ ദിസ് ആൻഡ് ദി ഹൊറിസോണ്ടൽ is 0. These are parallel lines. Okay, so if these are parallel lines, what do you know about it? That is this height, okay, and the same this height. What do you know about these two heights? If these are parallel lines, this height and this height is the same. So in that case, if this height is equal to x, okay, and then this height here will also be x. sorry, I'm going away from this. Just wait a moment. Zoom into it. Okay, now, okay, this is better. This is better. Okay, fine. So if this is x, then okay, your text is enter. Okay, fine. Fine. Right. And this distance is also x. I am unable to use that particular text to duplicate it. I don't know why. I don't want to waste time on it. So if this is x, this is also x. Okay, so this particular distance is easily identifiable. What is it? It is the distance of this person's eye from the ground. You can measure using a measuring tape. So if this person is looking straight at this through this particular instrument here, he or she will identify this point. So another person standing here, another person, okay, you can just see another person standing here. What she or he can do is he can mark with a chalk here, chalk piece here, which is the line. Okay, a mark here, a marking has been made here. Now what we do is this lady here, okay, if she can start shifting. Okay, let's select this and let us assume that this lady starts tilting her head upwards. Okay, more like now let's turn this like this. If you turn this like this, what happens is, okay, and let me slightly move it in such a way that you have a angle here. What you want is, you want her to look at exactly at the top of the tree. So when the line of sight matches, okay, now this becomes the line of sight here. Okay, now when she starts looking upwards and such a way that she just sees the tip of the tree. Okay, now what happens is, this particular cylinder or this particular instrument through which she is looking, she has tilted it upwards. So now as we have seen, what happens is, if we draw this shape, this becomes like an angle here, and we form an angle here. Okay, so this a curve is formed. Okay, an arc is formed. Okay, now this angle we will mark this angle as theta. This angle is theta. If this angle is theta, that what is the angle? Angle of the observer's line of sight with respect to the horizontal. If this angle, then what happens is she exactly looks at the tip of the tree. So sine theta. Oh, sorry, this theta, the angle is theta. Okay. Now, what happens is, can we measure this angle just by some kind of means? Some means can we measure this angle? Yes, we can measure this angle. Let us see how we can measure this angle. We can make an easy apparatus to measure this angle. Okay, let's see how we can do that. Okay, so here is what we do. In this case, we will have a device like a protractor. We fix it here, keep it in level to the horizontal line, and then we measure the angle it makes with respect to the horizontal using the protractor, or use some kind of device here which includes a protractor. So whenever you turn this particular instrument upwards, the angle is shown in the protractor instrument. So At any point of time, you can know how much angle of tilt is there with respect to the horizontal. This can be easily done using a protractor like instrument and attaching it to the this kind of binocular. So now that means we can measure this angle. Okay, this angle can be measured, and we have given the name for this angle is theta. So this becomes theta. So now what do we have here? We have a triangle here, and we know that we have, of course we assume that this is basically for this tree. We know it is perpendicular to the ground. So this line is basically like this. I'll reconstruct this on this side. Let us have a look at this. And draw the same circle on the side. Like this. So here we have the same circle here, the triangle here. Now this is a right angle triangle. This is a right angle triangle with this being the right angle. And this is theta. So if we name this as A, and then this is so this is where we face this problem. A, and here this is B, and this is C. We have this angle as theta. So basically what we have is, we can measure this distance. What we have is AB and BC and AC, right? This forms a right angled triangle where Pythagoras theorem can be applied, where you get AB square plus BC square is equal to AC square. Okay, but you don't know AB and BC. Of course you can measure AB, but BC is the height of the tree, or something like, from here to the height of the tree. So basically you get a right angle triangle with an angle theta here. Okay, that is what you should understand. And this angle is, now you already know this angle. And what else you know out of these three sides? You know this distance AB. This can be measured. What is AB? It is the, what is AB? AB is the distance. This is A. This is where this person stands. This is where this person stands. The distance from point where this person stands till the tree is the AB. So this is A, this is B. This can be measured using a measuring tape. AB can be measured. And now you have got this angle theta using the protractor like instrument on the binocular. Okay. So you have theta, you have AB. Also, if you say, you know that angle ABC is 90 degrees. Okay, so these are the information that we have right now. So let's pause here. So let's come to this right angle triangle and mark it once again on the screen. So we have this right angle triangle here. This angle, this one, and this line here. Okay, so this makes a right angle triangle with a angle here, which is what you call as theta. Okay, this is your theta, and this is basically your right angle triangle, and this triangle name, let us give it this A, B and C. So now here we have this triangle ABC with angle ABC is equal to 90 degrees and angle BAC is theta. So what is trigonometry is? Trigonometry is the science of right angled triangle, where we have, if you see the two angles, CAB and ACB. Okay, what can you say about this? You have any idea? Are they have any? Do they have any fixed patterns with respect to the size of these angles? Can any one of these angles be obtuse? Have you any idea? Because you can have a triangle like this, okay, where this angle is an obtuse angle, right? This is an obtuse angle. So in a right angle triangle, if this angle ABC is equal to 90 degrees, we already know that angle, okay, or we can call it as angle B. Okay, so let me delete all this, and I'm sorry, I'm right, angle B, angle one second, angle, okay, I'll reduce the point size. Angle B is equal to 90. Now we already know that angle A plus B plus C is equal to, you must be knowing it, three angles of a triangle, the sum of it 180 degrees, isn't it? Now we know that angle B is 90. Okay, so A plus 90 plus C is equal to 180, or A plus C is equal to 90. Okay, understood? That means A and C together add up to 90. Now what is an acute angle? Acute angle means less than 90. Now if A and C add up to 90, okay, so unless A is 0, so what is, if A is 0, how much will be C? 90. If A is 90, how much will be C? 0. So except for these conditions, so if A is 0, that means this A becomes 0, that means angle BAC, okay, this becomes 0, that means this AC and AB, okay, so this AC and this AB, both of them becomes equal, because when this angle becomes 0, that means this AC, this becomes smaller and smaller and smaller till the time this AC line coincides with the AB line. So AC will become equal to AB, and this shape will never be a triangle. It will cease to be a triangle, because as soon as AC becomes AB, it becomes a line segment, AC or AB, whatever. Because C and B will coincide with each other. This B becomes C also when the angle theta becomes 0. So that is not possible. Then this does not become a triangle. So the triangle aspect will only come for any angles of A above 0. So 0.1 degree also is okay. Then this will become 89.9 degrees. So it is 0.1 and 89.9 is C. That means both of them are acute. Understood? So that means in a right angled triangle, angle A or angle C, both of them will be acute. They can never be obtuse. This is a point which we should understand. So A or C can never be obtuse. Now let us come back to the original right angle triangle again, and we will see what is the trigonometry ratio. Still we have not got the relevance of trigonometry. We are still learning about the relevance of trigonometry. Endina trigonometry alle. So we will try to understand why it is, because we have defined certain functions called sine. Okay, sorry. Go to brushes. Okay, and we defined some values called sine, SIN, of the angle theta, which is defined as opposite side divided by hypotenuse. Okay, I hope you can understand this. Okay, now in this right angle triangle, if this angle is theta, which one? This angle is theta. What do you mean by the opposite side? Opposite side is the side opposite to the angle theta. Which is the side opposite to this angle? So first of all, you should know which are the sides of this triangle. So how many sides are there to the triangle? AB, BC, AC. Now the opposite side, simple. The opposite side, okay, is the side which is opposite to it. This side will never touch the angle theta. That is how you should understand. There's a simple way to understand it is, you have the angle theta. If you see the angle, how do you mark the angle? Like a arc. If you see, this is an arc, an angle, and this is an arc. Okay, this is how we measure the angle theta. So this angle is measured from here to here. Okay, so an arc is made. So understand, opposite side means a side which never touches the angle or that touches the arc. So if you see the arc, this side touches AC and this side it touches AB. The side which never touches is BC. BC is the side opposite to the angle theta. So opposite side is BC. BC. And what is hypotenuse? In a right angled triangle, the longest side is the hypotenuse, or it is the side opposite to the 90 degrees angle. Okay, opposite of the 90 degrees angle is called the hypotenuse, or the longest side of a right angled triangle is called hypotenuse. So it is obvious that this is the hypotenuse. Excuse my spellings here, because it's very difficult to write using paint. So this is the hypotenuse. AC is the hypotenuse. Now BC, as you have seen, it's the opposite side. And now what is AB? AB is called the adjacent side. Adjacent is the side which touches the angle theta. Adjacent. Okay. Now you will ask the question that, okay, hypotenuse AC is also touching the angle theta, right? Is it not adjacent? Yes, it is adjacent, correct. But we already have a term for the longest side of a right angle triangle, which is the hypotenuse. So which is also adjacent to angle theta. But for our terminology purpose, we already know that AC is the longest side, which is the hypotenuse. BC, which is the opposite to the angle theta. So it is the opposite side of the angle theta, and the adjacent side of the angle theta is the other side which is remaining, that is AB. AB is touching the angle theta. So one thing we all should understand, opposite side BC is the side opposite to the angle theta. Okay, it is the opposite of only angle theta, not for any other angle. For example, if you take angle C, this one, this angle, in that case the opposite side is the side opposite to it, which doesn't touch it, that is AB. Okay, AB is the opposite side of the angle C. Okay, so whenever we say opposite side, we have to ask the question of which angle. So for angle C, the opposite side is AB. For angle theta, which is angle A, the opposite side is BC. But will the hypotenuse change with respect to the angle? No, it will not change, because hypotenuse of a right angle triangle is always the longest side. Always the longest side. So I hope you are not confused. If you are confused, take a paper, draw a right angle triangle, mark all its sides as vertices as A, B and C, and you define, you understand, try to understand what is hypotenuse. So first you locate the hypotenuse. Okay, after drawing the triangle, the first thing to locate is the hypotenuse. Without asking any question, will you be able to identify the hypotenuse of a right angle triangle by just looking at it? Because visually it is confirmed, because the longest side of a right angle triangle is the hypotenuse. The first thing that we always need to identify is that, the hypotenuse. Of course, the other thing to identify is which is the 90-degree angle. Of course, you look at the right angle triangle, locate the 90-degree angle, and then you find the hypotenuse. We have a cross check. The hypotenuse will always be the opposite of the 90-degree. The 90-degree angle, if it is, this is 90-degree angle, the opposite side of this 90-degree angle is the hypotenuse. That is another way of looking at it. So the longest side of a right angle triangle is the hypotenuse. And then we define any of the angles. So we know in a right angle triangle, we already learnt the other angles other than 90 degrees. The other two angles, angle A and angle C, both of them can never be obtuse. They can never be obtuse. Very important. So now we know each of those angles has an opposite side and an adjacent side. For example, if we take theta or the angle A, the adjacent side is AB. The opposite side is the side opposite to it, which is BC. Okay. So sine theta is a function of the angle theta or angle A. So sine theta can be written as sine theta, or you can also write as, of course, theta is just for, showing you that we also use the term theta. Sine of A, because A, this is angle A. What is the angle A? Actually, it is angle CAB. The short form of angle CAB is A. The sine of A, it is sine A. When you are writing it, it's not sine into A. It is sine of A. It is like this. It is sine of A. It is a function of the angle A. So sine of A is defined by opposite side of the angle A. Is basically opposite side of angle A divided by hypotenuse. Of course, it is not angle A. Hypotenuse can be of the right angle triangle, because hypotenuse does not change. So opposite side of angle A is which one? BC. BC divided by, what is the hypotenuse? AC. Okay. So sine A or sine theta is the same, because A is the angle theta we have marked here, is equal to BC divided by AC. Okay. So we get it like this. Sine A is equal to BC divided by AC. Okay. So let us have a look at it again, because I have drawn it clearly for you, because otherwise it was too shabby. Okay. Though I have drawn this right angle triangle clearly, and now identify the hypotenuse, which is the longest side. Okay. So what we write? Hypotenuse is AC, right? Okay. Can we write it here? Okay, we will write it here. AC is equal to hypotenuse. Okay, fine. Right. So AC is the hypotenuse. Now we will talk about angle A, which is the opposite side of angle A. Tell me which is the opposite side of angle A. Right, opposite side of angle A equal to opposite side of angle A, as we know, which is angle theta also, the angle which doesn't touch the arc, the side which never touches the angle A. Angle A is this one. So this is one side and this is another side, AB and AC, which both of these touch it. The side which doesn't touch is BC. So BC is the opposite side. Okay, let us make it like this. Okay, and just move it so that it becomes fine. This is opposite side of angle A is equal to BC. And now we will locate the adjacent side of the angle A. Whenever we are saying adjacent side, we are always talking about a particular angle. So adjacent side of angle A is which one? Again, tell me. Adjacent side of angle A. Adjacent side, okay, of angle A equal to AB. Okay, fine. So that also we will just make it out here and just make it here and here. This is adjacent side of angle A. So this we understood, right? So looking at any right angle triangle, if you look at any particular angle, acute angle, of course, which is the acute angle here, angle A or the angle C. B is the right angle triangle, right angle. Okay, B is the right angle. Okay, B is the right angle. So of course we should mark as the right angle. Let us mark this right angle. Sorry, this I forgot to make it like this. Okay, fine. This is the right angle. So now we have a relation with respect to this in trigonometry. Trigonometry is a science of relations of different sides of a right angled triangle. Okay, so we have the first relation, which we define a new term called a function called sine, S-I-N-E, sine of angle A, which is also denoted in short form as sine A is equal to opposite side divided by hypotenuse, which is equal to, which is opposite side of angle A is BC divided by hypotenuse AC. This is what we get, sine A. This is the first relation that we get. This is the first trigonometric relation that we have with respect to angle A in a right angled triangle ABC. Okay. The same way we define another function. Now why do we define all these functions? You will come to know later. Okay, these relations are very important. First, when we let us define it, and then I'll tell you why it is important. Okay. Now we have sine A. We have defined sine A as opposite side divided by hypotenuse. Now we have the next one, which is the cosine of A. This is the cosine. Now you must be asking why I am not talking about theta. I can write theta also, which is equal to A. Of course, because of time limitations, I am not writing it. I hope you will understand it. Theta is a term, it's a Greek term used for representing variable angles, just like X, Y, Z and all. So it is just a variable. So now cosine A is another function, which the short form of which is cos of A. It's actually basically is cosine of A. It is cos of A. It's a function. It's not a product. Okay. is equal to adjacent side divided by hypotenuse, which is equal to, which is the adjacent side of the angle A here, AB, divided by hypotenuse is AC. So this becomes your second rule, or second function in the trigonometric function is cosine of A. Fine, that is done. The next one is tangent of A. Next one is what? The tangent of A. You have to learn this. This has to be something like by hearted. Tangent of A, the short form is tan A, which is equal to opposite side divided by adjacent side. Now this is also equal to, which is basically the first definition of tan A is actually sin A by cos A. It is actually a division of sin A by cos A. It is nothing but a ratio of sin A and cos A. So if you try to find out why it is actually sin opposite side by adjacent side, simple. If you see this, you can derive tangent A. What is tangent A? Is tan A. Tan A is sin A by cos A. Okay, this is what we should know. So you define sin A, you define cos A. This is very important to understand. Then you define tan A, which is actually a ratio of sin A and cos A. Sin A divided by cos A. So define sin A, then cos A, then sin A by cos A, which is called tan A. Now you can find out, if you replace the sin A by BC by AC and cos A by AB by AC, or sin A by opposite side by hypotenuse and cos A by adjacent side by hypotenuse. So instead of sin A, if you substitute opposite side by hypotenuse, and instead of cos A, if you substitute adjacent side by hypotenuse, the hypotenuse cancels off, and you will get tan A is equal to opposite side by adjacent side, which we will get, and that is also equal to, we will get as opposite side is BC, adjacent side is AB. So you will get, the final answer is that BC by AB. So let us write that also here. It is BC by AB equal to BC by AB. Okay, sorry, I have to put it back here, somewhere here. Okay, let me find out how I can take it inside. Slightly going here. So excuse me for this. Okay, so I have typed it here, BC by AB. So tangent A is BC by AB. Now we have three functions, sin A, cosine A, tangent A, which is in short form it is called sin A, cos A and tan A. Okay. Now what do we have is basically the reciprocals of these three. Nothing else other than the reciprocals of these three. We have to learn the 6 functions here. Sin A, cosine A, tangent A. Now comes the reciprocal of each one of them. So instead of sin A, we will define a new term which will be equal to 1 by sin A. Okay, the reciprocal is 1 by sin A, right? So we define a new term called cosecant. Cosecant A. Cosecant A. Short form, we cannot write cos here because cos is already there. Short form is cosec of A is equal to 1 by sin A. What is 1 by sin A? If sin A is opposite side by hypotenuse, then what is 1 by sin A? Hypotenuse by opposite side. By opposite side, which is equal to, which is the hypotenuse here? AC, which is the opposite side of angle A? BC. Okay, so this is what we have, cosecant A. So we defined something called cosecant A. Move it here. We have the next third one here. So cosecant A is 1 by sin A. Okay, 1 by sin A is cosecant A. You have to by heart this one. Okay, I'll tell you certain ways you will not confuse. Sin A, sin A, cos A, tan A. Of course, you have to understand how sin A and cos A is the first thing you have to learn, and then we have to learn tan A, which is equal to sin A by cos A. The relation is that. So let other things you can find out easily. Then cosecant A. Now you know that we have defined sin A, cos A, tan A. The next three will be 1 by sin A, 1 by cos A and 1 by tan A, because we are learning about reciprocals. So first one is 1 by sin A, which is called cosecant A, which is cosec A. The second one is secant A. So there is no cos here. Secant A. We remove the cos from the co from it. Cosecant. So we remove the co from it, so it becomes secant A, which is the short form is sec A, which is equal to 1 by cos A, which is equal to what? If cos A is, if you know that cos A is adjacent side by hypotenuse, so 1 by cos A is reciprocal is hypotenuse by adjacent side, which is equal to simple AC by AB. Understood? AC by AB. Write it here. Now please note. Now you have a confusion here. I always had this kind of confusion that because this sec and cosec. Now this cosec, if you see, there is a cos here. Okay, this will create a kind of illusion. I had this illusion because I thought this is related to the cos. Okay, this, but actually it is not. Okay, do not get confused that cosecant A has anything to do with cosine A or cos A. So the best way to remember is, if you have a doubt, if you by mistake, if you say cosecant A is 1 by cos A, ask yourself, you tell that cosecant is not related to cos, then it has to be sine, not cos. Okay, cosecant A is the reciprocal of sine A, not cos A. Okay, because once you come to the reciprocal of tangent A, we will come to know that you cannot get confused with that. The only confusion will come between sine and cosec. Okay, so cosecant is the reciprocal of sine A, not cos A. Remember this. So you have to find a way in which to remember this. Okay, so next one comes as third reciprocal, is we call it as cotangent A. Cotangent A, which is short form is cot A. Cot A, which is equal to 1 by tan A, which is equal to, what is tan A? If tan A is sin A by cos A, which is so 1 by tan A will be cos A by tan A. That is the first thing you should know. Cos A by sin A. Cos A by sin A is also equal to, now we know that tan A is opposite side by adjacent side, because so cot A will become adjacent side divided by opposite side, which is equal to, we'll have AB by BC. Oh, okay. Okay, I'll have to type again because of this. Cotangent A is equal to cot A is equal to 1 by tan A, which is equal to cos A by sin A, which is equal to adjacent side by opposite side, which is equal to AB by BC. Now let us make it straight here. Okay, it became too big here. Okay, this is okay. This should be fine. Yeah, here No. Okay, this should be fine. Okay, so we defined all the functions here: sine A, cos A, tan A, cosec A, sec A, cot A. Please, we have to learn all this. We have to learn all this. So what we have to learn is sine A is opposite side by hypotenuse. Tan A is, no, sorry, cos A is adjacent side by hypotenuse. Then tan A is the ratio of sine A and cos A, which is sine A by cos A. So we will get it as opposite side by adjacent side. And all the next three functions are the reciprocals of all these three functions which we defined initially. First one is cosec A, which is the reciprocal of sine A, or 1 by sine A. Then secant of A, sec A, which is the reciprocal of cos A, 1 by cos A. And then we have cotangent, which is cot A, which is the reciprocal of tan A, so 1 by tan A. So simple, only this much we have to learn. Now let me talk about why it is important and why do we have to learn it. Is because these values of sine, cos, tan, etc. for any angle from 0 to 90 is available in the form of tables. This ratio is fixed. For example, if the angle A is 30 degrees, there is a particular value of sine A. Understand? It is a constant. This is why we are talking about this. For example, the angle sine A, we have a constant value. This does not change. Okay. It means if the angle A, which is theta, is 30 degrees, the opposite side by hypotenuse, which is sine A, which has a standard value, it doesn't change. Okay. So that means we get a ratio of BC by AB, which is a constant. So if we know BC, we will be able to know AC. I'll be more clear if we come to the tree analogy. Okay, to find the height of the tree, the person looking at the tree. Let's go and look at there. Okay. Okay, let us look at this right angle triangle now. Okay, just before going back to our model of the tree and the character, the person looking at the tree, just we will see what is the application of this trigonometry and why, how it can be used further, and what is the real basis based on which trigonometry is used so much prolifically. Let's have a look. So this is a right angle triangle, and as you know, ABC, this angle A we are talking about, we have talked about opposite side. BC is the opposite side, AB is the adjacent side, AC is the hypotenuse. And also Pythagoras equation. Do we remember Pythagoras? Okay, Pythagoras says AB square plus BC square is equal to AC square. Is it right? Can we write down our Pythagoras equation here? Okay, let's write down with the text here. So AB square for right now. Square is a subscript. So I don't know how to format it as a subscript. So okay, let us assume this AB2 is AB square plus BC square is equal to AC square. Of course, it is not AB2 BC2, it is AB square BC square AC square. Okay, or I think I can do it in a better way. You can write like this. I will add more text here. And I will just yeah, this makes it AB square, and I will add another 2 here and move it near this particular BC, so it becomes BC square. Okay, not really correct, but should be okay. And this one becomes AC square. Okay, so AB square plus BC square is equal to AC square. This is by Pythagoras, you know. Now we also know that sine A is equal to, what is sine A? You remember sine A? Sine A is equal to opposite side by hypotenuse, that is BC divided by AC. Okay, now I will tell you what is the basis of trigonometry. The basis of trigonometry says that sine of any constant angle, okay, for example, this angle A is equal to 30 degree. If angle A is equal to 30 degrees, let's write it here. The basis is any trigonometric ratio. Which is a trigonometric ratio? A sine, a cos, a tan, a sec, a cosec, a cot, etc. Any trigonometric ratio of a constant angle is a constant. This is the basis. Okay. So you may not get it anywhere, but this is the correct basis of it. Any trigonometric ratio of a constant angle is a constant. For example, if we take the angle A as 30 degrees, okay, if we take this angle as 30, then we have sine of 30 is equal to, this is a value you have to learn. Of course, you will have a tables for this, 0.5. Okay, or you can write sine of this 1 by 2, that is equal to 0.5. This is the value of sine 30. Okay, this is the value of sine 30. So this we should understand, and let's go and see. This is a Google. In Google, just put trigonometric tables. You find this. This is a sheet. Okay, I hope you can see this trigonometric tables, and this is a sheet here which lists each degrees. Of course, this is radians. This is degrees 0, 1, 2, 3, 4, and the value of sine theta, sine x, cos x, tan x for this particular angle. For example, sine 1, sine 0, sine 1, sine 2, if the degrees. So we defined angle A as equal to 30 degrees. So we go and have a look at 30 degrees. Okay, this is 30 degrees. For 30 degrees, this is the sine value. If you see the sine of 30, sine of x, sine of 30 is 0.5. It is listed here. That means for 30 degrees, the sine value is always 0.5. So coming back to our picture, what we understand is sine 30 is 1 by 2. In that case, if this angle is 30 degrees, the ratio of BC by AC is equal to 0.5. It is a constant. So that means if this is 30 degrees, then we get BC by AC. What do you understand? Sine 30 is what? End of the day, sine 30 is BC by AC. BC by AC is equal to 0.5. Or we get BC is equal to 0.5 into AC. This is what we get. So what we understand is BC is equal to 0.5, half of AC. Hypotenuse is AC, BC is half of AC. That means if you already know the angle, and if you know any of these side, okay, if you know AC, you can find out BC. For example, if I know that AC is equal to 5 meters, if AC is equal to 5 meters, we'll write as 5 here. If AC, we know it is the value is 5. I want to move it. Okay, this is 5. Then you have BC is equal to what? BC is equal to 0.5 into AC. 0.5 into 5. That is equal to 2.5. Okay. So this becomes 2.5. And now you get this angle, this side. Now you have two sides. Now you can use any formula. Okay, you can use Pythagoras equation, a theorem. If you know this is 5, this is 2.5, you can calculate this by this Pythagoras. Or since this is 30, you have adjacent side is AB. Okay, what is cos 30? Cos 30 will be is equal to adjacent side divided by hypotenuse, AB divided by AC. We already know AC is equal to 5. Now we have to find AB. For that we should know cos 30. Again, go to our table. The table, if you see, list cos x here. List cos x here. So for 30 degrees, if you see the cos value is this one, 0.866. This is 0.866. So we get cos 30 is equal to 0.866. Cos 30 is what? Adjacent side divided by hypotenuse. So adjacent side is AB, we do not know. Hypotenuse we know it is 5. And the value of cos 30 is equal to 0.866. So from there we can find out what is the value of AB. Or otherwise, since we already got BC here, this side we already know 2.5. As I told you before, hypotenuse also is given as 5. So two sides of the right angle triangle is known. The third side can be easily found out by this relation, the Pythagoras theorem. And this also you will get. So understood. So why is it important? Now let us come to the tree. Again, repeating once again, if we know this angle of a right angled triangle, of course this has to be a right angled triangle, then only you can follow this particular rule. This is a right angled triangle, okay, and if we know any one of the angles other than this 90, of course 90 is known. If you know one of the angles here, of course if you know one of the angles 90, if this is an angle which is known to us, then if one side is given, if any one side is given, we can calculate all the other sides. We can calculate all the other sides. So we need to just measure one angle here. Okay. Now can we go back to our picture and let's to the tree thing, and can we find out whether we understand anything out of it? This one. Yeah, just hold on. Let's load that project and let's see what is there, you know. Hold on. It's still loading. Okay. Now, if you remember, we have plotted this particular diagram. The person is looking at the top of the tree, and this particular instrument is making an angle of theta with respect to the horizontal. This is the horizontal, and this is the tree. Okay. Now, basically, by keeping a protractor, this person was able to measure this angle theta. Okay. So this theta is known. It's an angle which is known, maybe 30, 40, depending on what this person has seen. So in this case, is it not a triangle here? Right angle triangle, assuming that this tree is perpendicular, it is exactly vertical. So this is a triangle with vertices. Can we mark the vertices as, okay, let's mark the vertices here. This will be the first vertex, which is A. Okay, is it too big? Okay, it's too small. It is too small here because the canvas is very big, pretty big. And we want still bigger one. Okay, we make it 130. No, it is very big. Make it 72. Okay, 72. This is fine. And we just move this to somewhere here. So this will be A. This point here will be B. This point here will be B. Okay, and where will be C? The C will be here. Okay, so this will be a right angle triangle. Okay, this is a right angle triangle. Now here, now we have A, C, and B. Okay, now what do you have the relation here? Let us reduce this to 28. Okay, now size to 28. Now let us see what happens here is we have a right angle triangle. We have this angle theta. Now what is the relation? What is this height? What we can measure already is AB. We already told that what is AB? AB is the distance of this person where she is standing from there till the tree. Okay. This is AB. This, as we told, okay, this particular line, as we had already mentioned, this distance, as we already mentioned, this can be measured using a measuring tape. Okay, so AB can be measured. So if we know AB, what is AB with respect to theta? Is it the adjacent side or the opposite side? For theta, this is the adjacent side. Okay. So what is cos theta? Or okay, Fine. Now we want what? Fine. Cos theta is adjacent side by hypotenuse. Now we will try to directly derive what is this side. Okay. Now what is this side? This is the opposite side. This is the adjacent side. We already know what is the adjacent side. We want to know what is the opposite side. So which is the formula which has both the opposite side, adjacent side and the angle? It is tan theta. Tan theta is equal to opposite side divided by adjacent side. This is the formula we have got for tan theta. Okay, let's just make it up here. Let's write it. The size is very small. Okay, tan theta, or instead of theta, I'll write the angle A because it's the angle A, right? Tan A is equal to it is equal to sin A divided by cos A. That is the formula. That is also equal to opposite side divided by adjacent side. Okay, let's make this bigger. Right now we don't want this relation anyway. This is just for your information. This is also a formula. Okay, tan A is equal to opposite side divided by adjacent side. Now what is the opposite side? We already know. Okay, now again tan A is equal to, what is the opposite side is BC divided by adjacent side is AB. What is this equal to? What is BC? BC is still BC divided by AB. We already know a particular value. Okay, put some value for it. So assume that we got this has 5 meters. Okay, 5 meters. BC divided by 5, because if it is a problem, we think that this particular distance from here, this person is standing from the tree, this distance someone measured using a measuring tape and found out this to be 5 meters. Okay, this much is 5 meters. Okay, now we get tan A is equal to BC divided by 5. Okay, now as we told earlier, this particular angle can be measured using a protractor. What she did, she held this horizontal first, then someone used a chalk piece here and marked here. Okay, and then what she did is slowly she tilted this upwards. By the time she will be able to exactly see the tip of the tree, at that time there was an instrument, a protractor here. With that she measured this angle from the horizontal. She got exactly the angle theta that is measured, and then she already knows this distance AB. Now what we need is to calculate the distance BC. So now if assume that this theta was measured to be how much? Let us say 45 degrees. She got theta as 45 degrees. Okay, for the tree. So given as theta or angle A. Okay, we have A is equal to 45 degrees. Angle A. Okay, so now what does tan A become? Tan A is equal to tan 45. From where will we get tan 45? Right now we will go to Google and see the table again of tan value. Okay, this is the tan x value and we need the angle and degrees of 45 degrees. Okay, go to the 45 degree one and we could look for the this tan value here. This is the tan value. This is 1, 2, 3, fourth one. So we go for 45 degrees and 1, 2, 3, fourth one. Tan 45 is 1. Okay, that's exactly 1. So what we do? We substitute this value here. Tan 45 is equal to 1. Okay, this is equal to 1. So we get tan A is equal to tan 45 is equal to 1. Now what do we get? Tan A is equal to opposite side divided by adjacent side, which is BC by 5. Therefore from this and this what we get is BC by 5 is equal to 1. We get what? We get BC by 5 equal to 1. Therefore BC is equal to 5 meters. And what is BC? BC is this distance. Okay, BC is this distance. Now what is the height of the tree? The height of the tree is equal to this distance x plus BC. Height of the tree is equal to, let me make it bigger. x plus BC, that's equal to x plus 5 meters. Okay, now height of the tree is equal to x plus BC. What is x? X is actually, if you see, x is the height of the person, height of the eye line of the person. This can be measured very easily. The distance from the eye of this person to the ground can be measured. The same, the chalk mark was made here. So that chalk mark can be measured with the help of tape, measuring tape here. You get x and then you add it to 5, you get the height of this tree. And how did you get the height of the tree? Without actually measuring using a measuring tape. What you only needed is a small instrument here to look at the tip of the tree. Nothing else, just like a telescope, a fine telescope. Nothing else was needed, and a measuring tape. So a very tall object, the distance of the height of a very tall object was easily measured without actually measuring the distance or the height. If it is a very tall thing like a star, just imagine how we can judge the height of a star with respect to this by just doing the simple calculation using this degrees. So estimation is very easy. Okay, so all these are trigonometry is used for astronomy also. Okay, this has got very profound implications. So this you can also use, you can just use, because with very small just a small tube, so a cylindrical tube, right? That is what this particular thing is. You can make an apparatus and you can look at a particular thing from a point. You can actually practically check, okay, height of a tower or something, just to estimate the height of a tower, you just need a small binocular like thing like this, and the angle you can roughly estimate. If you really know how to estimate an angle, because 90 degree you already know how much it will be. 45 you can easily estimate, it is half of 90. It's after some experience, it is very easy for you to judge what is 60, what is 30 and all. So just by standing somewhere, you will be able, with the help of some small object like this, sometimes you may not even need this. If you have experience, you only need your hand. You make a small cylindrical fold out of your hand, look at the top of a tower just like that, and you can estimate what is the angle you have tilted your hand. And once you just estimate the angle, you are able to judge the height of that tower by knowing how far away you are standing from that tower. Okay, that also you can measure. For that also there are crude ways of measuring, rather than using your own a measuring tape or something. You can actually use the traditional method of steps. If you know how many steps of yours is a meter, you can easily calculate what is your distance from the tower. And then once you get the distance from the tower, and once you estimate the angle, you can immediately find out what is the height of the tower. So there are a lot of applications for this one. Human brain has evolved because of all of these things. Everything is there in your brain. Okay, because some people much before us have done all these kinds of thinking, and just because of this thinking our brain has evolved. Okay, everything is there inside your brain. You have to just think about it and recollect it. Okay, the only thing is we have to invest some time into thinking about it. Okay, so this is what it is. So this ends this module. I think you need to have a look at it and think about it. We will go into how to solve the problems and all, but you should get a base of it. You have to watch this video, you have to think about it, read the text again, and then find out what is it, what is trigonometry, and what are the basic things we have to learn and by heart also. Yes, the formula for sine, the formula for cos, the formula for tan, the formula for cosec, sec and cot. Okay, and right now you don't have to think about the different values of all the angles and all, the sine, tan and all that I had just told you, because this is the way it has to be taught, rather than what is there in the textbook. Some things have to be told to you earlier, and that's why I wanted to tell you about the sine values of 0, 1, 2, 3, whatever, showing from the tables. Okay, so that's it. Best of luck.